Hello, good morning, Math 142 student. This is a video for chapter 6.1. And in this video, I'm going to talk about how to find probability for a standard normal, Z, which is the Z-score representing the number of standard deviation a normally distributed variable is from. A normally distributed data is from the mean. So because it's standard normal Z, the mean is 0 and standard deviation is 1. You can represent a standard normal's distribution by a bell curve written here. And in 6.1, we have a few things that we want to do. First is to find probability that Z is in a range, in a certain range. And the idea is to find probability, we want to do percent relative frequency, which is kind of modeled by a relative frequency histogram and an area under the density curve. So if you are to find probability, you have to find the area under the density curve, which model how the histogram behave. So we talk about this in class for 6.1. The tools to find probability is not calculus, but we would use the graphing calculator, a command called normal CDF. You can access this through Distribute first, DISTR, and then select normal CDF. There is another command in that list, normal PDF, which we do not use. CDF is the one that gives us the area. So to find probability, we would enter normal CDF, lower, upper, 0, 1. So that's the command syntax. I can show you a graphing calculator here. So to do this, you do second var, which is distribute. Oh, turn it on first. Second var. And you will find normal CDF in the second command. That's what we usually use. Lower is the lower bound of the area that you want. Upper is the upper bound of the area. And then this mu is the mean, sigma is the standard deviation. And for standard normal, it's already input for you is 0, 1. This is a TI-84 calculator. So after you enter all those, they refuse to move. You press paste, and then it would come back to the command line, and you do it. In order not to confuse what you should be doing, usually we start off by clearing everything from the beginning before you do second var. Okay. So let's do some example. Go back to our notes. Or actually look at the syntax of normal CDF. So if our range is between two numbers, like this is the first case number A, and we want to find probability that it is between two numbers. So we'll draw the two number, two Z value here. We'll highlight it on the Z axis. So this is actually the Z axis, and this is the bell curve of Z, and that's area. So if say for example I have x1, x2, our lower and upper will be x1 and x2. This is the lower, this is the upper. If I want to find something that is greater than x2, say whatever value, 1.2, greater than 1.2, we say these are all greater than 1.2, or earlier I should say these are all number between x1 and x2, so the probability is here. And if we want to find probability greater than x2, we highlight it here. Then we have our lower here. Our upper number is infinity. And the calculator is 1e99. Okay, that's what you enter. And in this is low, and this is the upper. And if you want to find probability that Z is less than a number, say less than this number, so these are all some number that's low, and this is the area. So we would say, in this case, what is our low number? Our low number is actually negative infinity. Oh, they get in the way of each other. So in negative infinity, it will be negative 1e99. Okay. So this would be a low number, and this would be upper. Like x1, so this would be the upper now. So whatever, because it's the highest than everyone in this list. So that's the idea. So the example. So let's say we want to find probability that z is between negative 1.2 and 1.7. So you would draw negative 1.2, mark it here. So usually when you do this kind of question, you would draw a z normal curve. 1.7 is here. This is anything that is between negative 1.2 and 1.7. 1.7. Negative 1.2. And you say, well, to find probability is to find area. So we would shade this area. So it boils down to what is the area under this normal curve. So we say instead of using calculus, we would use normal CDF, lower, upper 0,1. In our case, our lower and uppers are very obvious. It's normal is negative, those two numbers. So you would do a normal CDF. Lower is negative 1.2, upper is 1.7, and 0,1. Close loose. Put in the calculator. Turn it on. Clear everything. Second, distribute the second one. Our lower was negative 1.2. Negative is the one that's next to the dots. 1.7, 1.7. 0,1 is already dead, so we just do paste. Press enter. 0.8404. So that's our answer. 0.8404 for 4 decimal places. The second example is if I am to randomly select a z and I want to find the probability that z is higher than 1.7 or greater than 1.7. Then I'll again do the normal curve. And I want to shade the number first so that I know what is the lower, what is the number. It's hard to think about what it is in your mind. So we would draw the normal curve. This is z. 1.7 is here. What are the numbers that's higher than that? So these are the numbers higher than that. And the area that above it would be the probability. So the command would, so we have our lower. What is our lower? Our lower is 1.7 because it's the lowest in this range. Our upper is, you can see that it is infinity, which is 1e99. Right? So we would type in the command so you can remember what it is. Normal CDF, open. 1.7 is lower. Upper is 1e99, 0,1. So let me show you how to do it in the calculator. So you would again clear everything. Second verb. The second one is normal CDF. Lower in our case is what was it? 1.7. Yeah, 1.7. And then our upper is 1. E is second comma. See this double E here is second comma, 99. And then 0,1 and you paste. Get your answer is 0.0446. 0.0446 equal 0.0446. That's unlikely, so it's really low chance to select a number that's higher than 1.7. So that's the higher than case. What about what's the probability that z is lower than a certain number? So in this case, in this example, we want it to be lower than negative 1.3. So again, we graph the z normal curve. We want to find probability. Find probability is finding area. And we have lower than 1.3. Where is negative 1.3 is here. All these are lower than negative 1.3. So it's point to the left area, right? It point to the only area on this left side. So in this case, what is the lower number? It's not negative 2. The lowest that you can go, it actually goes on forever, is negative infinity, meaning negative 1e99. The upper number is actually negative 1.3. Okay, negative 1.3. So the command to do it would be normal. Oops, not that side. Normal CDF, negative 1e99, comma, negative 1.3, 0,1. Okay, so that's how you do. What's the answer? So go to the calculator, clear everything, second verb, normal CDF, lower is actually -1. Second comma for E, 99, and we would say, what was it, 1.3? 1.3, I think. 0.1 paste. Press enter, 0.9032, 0.9032. So put the answer, oh no, it's -1.3. We got it, we got the wrong number. -1.3 actually. So they should have saved here. Oops, they are -1.3, not 1.3. No wonder is the number is so big. So it's 0.0968. 0.0968. So we put the answer 0.0968. The second goal that we want to do is to find cutoff for the lowest or highest percentage. So maybe we'll do this in the second video. Okay, so this video is to find probability of Z in a range.